Imagine this. You're floating in the silent emptiness of space, surrounded by billions of stars glittering like diamonds across the black velvet of the universe. Everything feels calm, almost peaceful. But then, far away, you notice a patch of darkness that looks a little too dark, like a hole ripped out of the sky itself. No stars shine there, no light escapes. It's as if the universe itself is hiding a secret. That, my friend, is the lair of one of the most mysterious and terrifying objects in the cosmos, a black hole. Black holes are the universe's ultimate do-not-enter zones. They're not just dark, they are places where the very laws of physics break down. You could throw in light, matter, or even the entire internet history you wish you could delete, and none of it would ever escape. For decades, black holes have been portrayed as cosmic monsters, devouring everything unlucky enough to wander too close. And honestly, that description isn't far off. But what exactly is a black hole? At its core, a black hole is nothing more than a region of space where gravity has become so strong that escape is impossible. To understand that, think about it for a moment. If you jump straight up, gravity pulls you back down. If you want to escape Earth's gravity, you need to travel at around 11 kilometers per second. That's Earth's escape velocity. Now imagine something so dense, so heavy, that the escape velocity isn't just 11 kilometers per second, or even 100,000 kilometers per second. Instead, the escape velocity is faster than the speed of light itself. And since nothing can go faster than light, not even light itself can break free. That's what creates the black hole. These monsters don't just appear out of nowhere. They are born in the most dramatic way imaginable through the death of stars. When a massive star reaches the end of its life, it explodes in a fiery supernova, blasting its outer layers into space, but the core collapses under its own gravity. If that core is heavy enough, about 3 times the mass of our sun, it keeps collapsing smaller and smaller until all of its mass is squeezed into an unimaginably tiny point. This point is called the singularity, the heart of the black hole, where density becomes infinite and physics as we know it just throws up its hands and quits. But the singularity doesn't float out there naked. It's hidden behind a boundary called the event horizon. The event horizon is like the ultimate point of no return. Cross it, and you're gone forever. Even if you had a spaceship capable of moving at light speed, you couldn't escape. Imagine the event horizon as the mouth of the monster. Step inside. Your dinner. The size of this mouth, the event horizon, depends on the mass of the black hole. Some are small, only a few kilometers across, created by dying stars. Others are supermassive black holes, weighing millions or even billions of times the mass of our sun, sitting at the centers of galaxies. The one at the center of our own Milky Way, Sagittarius the asterisk, is so massive that if it were visible, it would make our sun look like a tiny flashlight compared to a stadium floodlight. For a long time, even scientists thought black holes might be too weird to be real. After all, how do you study something that swallows light itself? But over the last few decades, evidence has stacked up. We've seen stars orbiting invisible objects, whipping around at insane speeds, hinting at something massive lurking there. We've detected ripples in space-time gravitational waves created when the black holes collide. And in 2019, we even captured the first actual picture of a black hole's shadow, proving these cosmic beasts really do exist. Still, black holes are terrifyingly mysterious. What happens if you fall into one? Do you get stretched into spaghetti? Do you travel through time? Do you emerge in another universe? These questions aren't just science fiction, they're real mysteries that scientists are desperately trying to solve. Black holes don't just swallow matter, they swallow our understanding of reality itself. Think of black holes like nature's ultimate prank. They take Einstein's rules of relativity, mix them with quantum mechanics, and then laugh at us as we try to make sense of the mess. They are the crossroads of the biggest mysteries in physics, places where time, space, gravity, and reality itself are twisted beyond recognition. And yet, black holes are not just destroyers. Ironically, they're also creators. By feeding on stars and gas, they can unleash powerful jets of energy, shaping galaxies and even influencing where new stars are born. In other words, the monsters of the dark might also be the architects of the cosmos. So here's the hook. We found the monster. We know it's out there. We've seen its shadow, felt its power, and traced its influence across galaxies. But the real question, the one that has haunted scientists and storytellers alike, remains: what actually happens inside a black hole? That's the mystery we're about to unravel. In the next chapter, we'll inch closer to the mouth of the beast, standing right at the event horizon, the ultimate one-way door of the universe. Step too close, and you'll never come back. But if you dare to peek inside, you might just glimpse the strangest reality of all. Picture yourself in a spaceship, drifting slowly toward the darkest patch of sky imaginable. Behind you, stars shine like eternal guardians, but ahead of you, everything dissolves into blackness. Your control panels beep nervously, as if to understand that you're getting dangerously close to something that isn't just dangerous. It's final. You are approaching the event horizon, the infamous boundary of a black hole. The event horizon isn't a physical surface. You won't bump into it like hitting a wall. Instead, it's an invisible line in space that marks the ultimate limit. Outside the line, you still have a chance to turn back. Inside, forget it. You're part of the black hole's collection. Now, astronomers like to call it the point of no return. But let's be real, it's more like the universe's most ruthless bouncer. Once you're inside, not even light gets past the velvet rope. From far away, the event horizon looks eerily calm. You might imagine chaos fireworks of destruction, swirling stars being shredded, but surprisingly, it's smooth. That's because of Einstein's relativity. If someone were watching you fall toward the event horizon from a safe distance, they'd see you slow down. In fact, to them, you'd never actually cross. You just hover there, frozen in time, growing dimmer and redder as your light stretched into infinity. To an outside observer, you become a permanent ghost at the edge of the abyss. But here's the trippy part. From your perspective, nothing unusual happens as you cross the line. No alarms, no sudden jolt, no welcome to your doom banner. One moment you're outside, the next moment you're in, without any way to mark the crossing. To you, time moves forward normally, but to the rest of the universe, you've basically disappeared forever. It's like being deleted from cosmic social media, no chance of recovery. This strange difference in perspectives is the heart of Einstein's general relativity. Space and time themselves bend under gravity's weight, and black holes bend them so much that reality itself becomes relative. Outside observers see one story, you see another. Both are correct, and yet they don't agree. That's the kind of headache-inducing paradox that makes physicists both excited and deeply frustrated. Now, let's talk about the neighborhood around the event horizon. Before you even touch the edge, the environment gets intense. Gas and dust falling into the black hole heat up to millions of degrees, creating a glowing accretion disk around it. This disk can shine brighter than entire galaxies, pouring out deadly radiation. So if you thought you'd get a peaceful fall, think again. It's like trying to jump into a bonfire made of starlight. And if the black hole is actively feeding, the radiation and plasma jets it spits out can stretch for thousands of light years. Imagine a monster that eats you and sprays its dinner leftovers across the universe. If, somehow, your spaceship survives all that and drifts close enough, the black hole's gravity begins to pull on you unevenly, the part of your ship closer to the black hole feels a stronger tug than the part farther away. This difference creates what scientists call tidal forces. You, however, might call it the spaghettification process. Yes, that's the actual term astronomers use, because you literally get stretched into a long, thin noodle. Forget Italian cuisine, this is cosmic spaghetti. But wait, it gets even weirder. Some theories suggest that the event horizon might not just be a simple line. It might actually be a kind of firewall, an invisible wall of high-energy particles that would burn you to a crisp the instant you touch it. Others think it might act like a hologram, encoding information about everything that falls inside. The truth? We honestly don't know. The event horizon is where our physics starts breaking apart, where Einstein's relativity and quantum mechanics clash in the ultimate showdown. So here you are, sitting on the edge of the universe's scariest secret. On one side, safety stars, planets, normal space. On the other side, the unknown, time twisting, space folding, and possibly the destruction of everything you are. And the most chilling part, you wouldn't even feel the moment you cross over. 1 second, you're fine. The next, you're trapped forever in the black hole's embrace. The event horizon is like the mouth of the monster, but the real horror waits inside. What lies beyond that invisible boundary? Is it instant death, a cosmic tunnel to another universe, or the start of the most bizarre journey through space and time imaginable? In the next chapter, we're going to step across the line. Hold your breath, because once you're in, there's no turning back. Welcome to the black hole's belly. You've crossed the line. No alarms went off, no warning lights blinked. It felt normal. But make no mistake, you've now stepped into the strangest, most unforgiving place in the entire universe. Welcome inside the abyss of a black hole, where reality itself becomes unrecognizable. The moment you pass through the event horizon, something eerie happens. The direction of space and time begin to switch roles. Outside the black hole, time always marches forward and space is the thing you can move through. But inside, space becomes a one-way street leading inevitably toward the singularity. While time becomes slippery and distorted, it's as if the universe rewrote its own rules. Moving forward in space now means falling deeper toward the singularity, whether you like it or not. No thrusters, no engines, no clever maneuvers can save you. Falling is no longer optional, it's your destiny. From your perspective, you might still feel like things are okay. The cabin lights glow, the ship hums, your heartbeat continues. But look closer, your sense of time is being twisted. A second feels normal to you. What if someone outside could still see you? Spoiler, they can't. You'd appear frozen forever at the edge. Inside, time flows as usual, but outside, you've already been erased from existence. You've effectively stepped out of the universe's timeline. Congratulations, you're now a cosmic ghost. As you drift inward, the tidal forces grow stronger. Remember the spaghettification we talked about? Well, here's where it gets personal. The closer part of your body feels a stronger pull than the farther part. At first, it's subtle, like stretching after a workout, but as you fall, the difference becomes enormous. Your head might feel thousands of times more gravitational pull than your feet. Bones snap, molecules rip apart, atoms are stretched. Like taffy, you become the universe's strangest pasta dish, elongated thinner and thinner until even your subatomic particles lose their shape. Romantic, right? But wait, it depends on the size of the black hole. If you fall into a smaller stellar mass black hole, spaghettification happens quickly, and you won't make it far before you're torn apart. But if you fall into a supermassive black hole, like Sagittarius asterisk at the center of our galaxy, the event horizon is so huge that tidal forces near the boundary are actually weak. You could float across without instantly being shredded. You might survive the crossing and even drift toward the singularity for minutes, hours, or longer before the real destruction begins. So yes, falling into a bigger black hole actually buys you more time to ponder your doom. Comforting, right? Inside the abyss, physics becomes maddeningly uncertain. Einstein's theory of general relativity gives us one story: you keep falling toward the singularity, a point of infinite density where the laws of space and time completely break down. But quantum mechanics, the physics of the very small, refuses to agree. According to quantum theory, information can never be truly destroyed. But black holes, well, they seem to swallow information and hide it forever. This contradiction is known as the infamous black hole information paradox. If your atoms, your memories, your entire existence fall into the singularity, are they erased from the universe? Or are they somehow preserved, encoded on the event horizon like a cosmic hard drive? Nobody knows for sure. Some scientists believe that the information might be smeared across the event horizon, stored holographically, while others argue that black holes eventually leak information back out through something called Hawking radiation. If that's true, then falling into a black hole isn't the end, it's just the start of a very long and very slow unraveling. Imagine your existence being dribbled back into the universe over trillions of years, like cosmic crumbs falling from the monster's mouth. But let's push deeper. The closer you get to the singularity, the stranger things become. Space is no longer a convoy, it ripples, stretches, and folds in directions that don't even exist outside a black hole. Time may stretch endlessly, or loop, or even stop entirely. Some physicists speculate that the singularity could act like a gateway, a bridge to another region of space-time, maybe even another universe. Wormholes, parallel realities, cosmic rebirths. Inside the abyss, these wild ideas are not science fiction, they're plausible guesses. And yet, the truth remains hidden, because no one, not even light, can escape to tell us what really happens. The abyss holds its secrets close and for now. All we have are theories, equations, and imagination. As you fall deeper, reality begins to blur. Your ship, your body, even your thoughts, everything stretches and warps in the end. Whether you're shredded into cosmic spaghetti or funneled into a new universe, one thing is certain: once inside the abyss, you are never coming back. But here's the twist: black holes might not just be cosmic prisons. In the next chapter, we'll explore what happens As you approach the singularity itself, the place where the universe's greatest mysteries are locked away, is it truly the end of everything? Or could it be the beginning of something new? Asterisk. You are falling deeper and deeper with no way to stop. The light of the universe outside has long disappeared. The comforting glow of stars, the warmth of familiar space, they're gone. Ahead of you lies only darkness. But at the very center of this cosmic void, something awaits, the singularity, the final destination of everything that dares to cross the event horizon. The singularity is not just a place, it's the breakdown of reality itself. Imagine squeezing the entire mass of a star, or even millions of stars, into a point smaller than the tip of a needle. Now imagine that density becoming infinite. That's what the singularity is supposed to be, a point of infinite gravity, infinite curvature of space-time, and zero volume. In short, it's where the math stops making sense. When physicists write the equations, the numbers don't just get big, they break, exploding into infinities. It's like trying to divide by zero in your calculator. The screen doesn't give you an answer, it just gives you an error. The singularity is the universe's error message. From your perspective, as you drift closer, things grow stranger. The laws of physics, the rules you've trusted your entire life, gravity, motion, time, start to melt away. It's as if the universe's instruction manual has been ripped up and tossed into the abyss. Even Einstein's general relativity, the most successful description of gravity we've ever had, collapses here. Relativity tells us gravity curves space and time, but at the singularity, that curvature becomes infinite. It's like a cosmic knot tied so tightly that no theory can untangle it. But this is where another contender enters the ring: quantum mechanics, quantum physics. The science of the incredibly small refuses to bow down. It insists that infinities can't exist in nature and that there must be a deeper truth. This clash between relativity and quantum mechanics is one of the greatest battles in science. The singularity is the boxing ring where these two titans fight for dominance. So far, neither has won. Some theories suggest that the singularity isn't really a point at all, but a fuzzy region where space and time dissolve into a quantum foam. In this foam, distances, times, and even reality itself flicker like static on an old TV screen. Others propose that black holes don't end in singularities at all, but in wormholes, tunnels to other parts of the universe, or even to entirely different universes. In that case, falling into a black hole wouldn't be an end, but a doorway. Imagine being stretched, shredded, and then boom, emerging in a brand new cosmos where the laws of physics might be completely different. Trippy, right? But let's not get too optimistic. Most likely, the singularity is a place where everything you are, your body, your atoms, your information gets crushed beyond recognition. It's the universe's ultimate trash compactor. To put it bluntly, you don't survive the encounter. Nothing does. For all practical purposes, the singularity is death itself. Still, the singularity might also hold the key to creation. Some scientists wonder if the Big Bang, the beginning of our universe, was itself a kind of singularity. If that's true, then perhaps black holes are like cosmic seeds. Each one might be birthing new universes on the other side, hidden from us forever. In that view, every black hole could be a portal to a fresh reality with its own stars, galaxies, and maybe even life. It's the ultimate recycling program. Death here, birth there. But here's the most maddening part we will never know for sure. No signal can escape the singularity to tell us its secrets. No probe, no telescope, no brave astronaut can report back. It's the ultimate locked room mystery, sealed away forever. The singularity laughs at our questions, taunting us with silence. As you finally plunge into the singularity, your sense of self dissolves, your atoms unravel, your information scatters, your very identity becomes meaningless. What was once you is now part of the singularity's unknowable fabric. Whether that fabric is truly an ending or the seed of something new is a question no one can answer. One thing is certain, though, by reaching the singularity, you've reached the edge of human knowledge. This is the frontier where science meets philosophy, where curiosity collides with mystery. And perhaps that's the real reason black holes fascinate us, not because we understand them, but because we don't. But don't worry, the story doesn't end here. In the next chapter, we'll explore how black holes affect the universe around them, not just as destroyers, but as builders, shaping galaxies and maybe even determining the fate of the cosmos itself. The singularity may be the end for you, but for the universe, it's just the beginning of something far bigger. You've survived the unimaginable, or at least your imagination has. You've stared into the singularity, that cosmic engine of destruction and mystery. But now let's ask the question that makes scientists, sci-fi fans, and late-night thinkers lean forward in their chairs. Can black holes let us travel through time? It sounds crazy, right? A black hole doesn't exactly scream time machine. It screams run for your life. But here's the twist. Black holes are built on Einstein's theory of relativity, and relativity is practically an instruction manual for bending time. Let's start simple. The closer you are to a massive object, the slower time runs for you, compared to someone farther away. This is called time dilation, near Earth. This effect is tiny. You have to sit near a black hole's edge to really notice it. Imagine two twins, one floating far away from the black hole, and one orbiting close to the event horizon. To the twin near the black hole, time ticks normally, but to the twin far away, their sibling's clock runs slower. A year near the black hole might equal decades or even centuries outside. It's the ultimate one-way ticket to the future. Want to time travel forward? Just swing close to a black hole and wait. When you come back, the universe will have moved on without you. Congratulations, you've skipped ahead in time. This isn't science fiction, it's real physics. In fact, experiments on Earth with atomic clocks have already proven tiny time differences. When one clock is closer to Earth's gravity than the other, a black hole simply turns that dial up to 11. But let's crank the speculation higher. Some scientists suggest that rotating black holes called curved black holes might contain pathways called wormholes. These are tunnels that connect one region of space-time to another. In theory, if you could safely pass through a wormhole, you might not just travel across the universe faster than light, you might also travel backward or forward in time. Imagine diving into one side of the wormhole near a black hole and emerging thousands of light years away, or millions of years in the past. Of course, that's a big if. Wormholes, if they exist, are thought to be unstable. They collapse faster than you could fly through them. To keep them open, you need something exotic matter with negative energy density, sometimes called exotic matter. We've never seen such stuff in nature, but the math says it could exist. If it does, then black holes might not just destroy, they might connect. But here's where it gets even more mind-bending. Time travel to the future seems allowed by relativity, but time travel to the past creates paradoxes. The famous grandfather paradox asks, if you go back in time and prevent your grandparents from meeting, how could you exist in the first place? Black holes raise the tantalizing possibility that these paradoxes aren't just thought experiments, but real consequences of physics. Some scientists argue that the universe has a kind of self-consistency law, that if time travel exists, events must unfold in a way that prevents paradoxes. In other words, you could go back in time, but you could never change the past. You'd be trapped in a loop where your actions were always part of history. Creepy, huh? Others believe that if black holes or wormholes allow backward time travel, then every choice creates a new branch of reality. Prevent your grandparents from meeting, no problem. In one universe, you vanish, but in another, you never existed. To cause the change, black holes, then, might not only bend space and time, they might also fracture reality itself into an endless multiverse. And while these ideas sound like the plot of a Christopher Nolan movie, they're grounded in genuine physics. Black holes don't just challenge our understanding of matter and gravity, they challenge our understanding of time itself. If one day we learn to master them, we might discover that time travel isn't fantasy, it's hidden in plain sight, deep within the cosmos. So next time you stare into the night sky and wonder if time travel is possible, remember, the universe has already built machines that bend time. They're out there, lurking in the darkness. The only question is, will we ever be brave or crazy enough to use them? In the next chapter, we'll zoom out and see how black holes aren't just destroyers or time machines, they're also cosmic architects, shaping galaxies and perhaps even deciding the fate of stars like our own sun. Asterisk, black holes don't need laser beams, death rays, or alien technology to be the most powerful engines in the universe. They simply exist, and their presence alone is enough to bend the will of stars, devour matter, and light up galaxies like cosmic fireworks. Welcome to the chapter where we stop seeing black holes as just destroyers and start to recognize them as engines of unimaginable power. First, let's talk about their appetite. Black holes feed on matter, but they don't do it quietly. As gas, dust, or even unlucky stars fall toward the event horizon, They form an accretion disk, a swirling whirlpool of material spinning at nearly the speed of light. Friction and gravity heat this disk to millions of degrees, releasing more energy than an entire galaxy of stars. Yes, you heard that right, a single black hole can outshine billions of suns. When it's feeding, astronomers call these feeding monsters quasars, and they're so bright we can see them across the universe, even though they live in galaxies billions of light years away. And the spectacle doesn't end there. From the poles of these spinning monsters erupt relativistic jets, narrow streams of particles, blasted out at nearly the speed of light. Imagine the universe's biggest flamethrowers, spewing radiation and matter across thousands of light years. These jets are so powerful they can regulate entire galaxies, heating up interstellar gas and deciding whether new stars can form. Black holes don't just destroy, they control cosmic evolution. In a way, they are like the bosses of galaxies, shaping the growth and fate of everything around them. But their power isn't just about brightness or jets. They also have the power to tear apart stars in spectacular displays, called tidal disruption events. When a star wanders too close, the gravity of the black hole rips it apart, stretching it into spaghetti, shredding it, and feeding on its remains. Astronomers watching from Earth see a sudden flare of light as the black hole swallows the stellar corpse. It's brutal, but it's also one of the most incredible natural fireworks shows in the cosmos. Black holes also power something more subtle. They're galactic anchors. At the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole millions or billions of times the sun's mass. These giants keep stars orbiting in graceful spirals, stabilizing the galaxy's core. Without them, galaxies might never have formed as we see them today. The irony is striking. Something so destructive is also essential for creation. Without black holes, the universe will look nothing like it does. And then there's the power of mystery, their ability to force us to think beyond the limits of physics. Black holes are laboratories for extreme science. They test relativity, quantum mechanics, and even our imagination. Every time we study them, they give us new puzzles like dark energy, dark matter, or the nature of space-time itself. In this way, their power extends beyond physical destruction. It seeps into the very fabric of human curiosity. But perhaps the most jaw-dropping realization is that black holes are the most efficient power plants in the universe. Nuclear fusion, the process that powers stars, converts about 0.7% of mass into energy. Black holes, through accretion disks, can convert up to 40% of matter into pure energy. That's 6 times more efficient than fusion. If we could harness a black hole, we'd have an energy source capable of fueling civilizations for billions of years. Forget solar panels, just toss garbage into a black hole's accretion disk and collect enough power to light up entire worlds. It sounds like science fiction, but it's rooted in physics. Of course, harnessing such a monster would be like trying to tame a hurricane with a butterfly net. Black holes don't play nice, but the sheer thought that such power exists quietly, humming in the hearts of galaxies, is humbling. They're not just cosmic monsters, they're cosmic engines. In the next chapter, we'll step away from the raw power and focus on something even more haunting: the connection between black holes and the ultimate fate of the universe. Could these monsters decide how everything ends? Black holes are not just cosmic monsters feeding on stars. They may also hold the key to the ultimate fate of the universe itself. Imagine the far future, long after our sun has burned out, long after galaxies have stopped forming, when the universe has grown old and cold. In that distant future, black holes will be the last titans standing. Let's fast forward trillions of years. Stars will die, galaxies will dim, and new stars will no longer be born. What's left are white dwarfs, neutron stars, and most importantly, black holes. These monsters will dominate the cosmic landscape slowly. They'll swallow whatever matter drifts close: dead stars, planets, gas clouds. Galaxies will become graveyards ruled by supermassive black holes at their centers. But here's the twist: black holes aren't truly eternal. Thanks to a discovery by Stephen Hawking, we now know they can slowly evaporate over time. This process, called Hawking radiation, happens because quantum mechanics says even empty space isn't really empty. Tiny pairs of particles constantly pop into existence. Near the event horizon, one particle can fall in while the other escapes, stealing just a tiny bit of the black hole's energy. Over eons, this process will cause black holes to shrink and eventually vanish in a final burst of radiation. The timescale, though, is mind-shattering. A black hole with the mass of our sun would take about 10 years to evaporate. That's a number so big your brain can't even picture it. It's far longer than the current age of the universe. Supermassive black holes will take even longer, up to 10 years. That's a Google years, the kind of number you only hear about in math class. In other words, black holes will outlive everything. They will be the final fireworks of a dying universe. So what does that mean for us? It means the universe's story ends not with stars, not with galaxies, but with black holes quietly fizzing away into nothingness. This future is often called the heat death of the universe. By then, there will be no more usable energy, no more light, no more life, just darkness, silence, and the faint glow of black holes evaporating into the void. But here's where it gets even stranger. Some scientists speculate that when black holes evaporate, they might not just vanish. They might release the information they swallowed or even create new universes in the process. Imagine each black hole in our universe as a seed, growing into a baby universe on the other side of reality. If that's true, then maybe black holes aren't the end at all. Maybe they're bridges to new beginnings, and then comes the ultimate philosophical question. If black holes birth new universes, could our own universe have been born from one? Are we living inside the other side of a black hole from a parent universe? Suddenly, black holes aren't just the monsters at the end of time. They might be cosmic worms, endlessly creating new realities. It's a haunting thought. The universe ends in darkness, ruled by black holes. But perhaps, somewhere beyond, something new is born. In the next chapter, we'll step away from the cosmic endgame and look at how we humans are trying to see, study, and even photograph black holes, turning the monsters of theory into real images that prove they exist. Asterisk, how do you take a picture of something that doesn't let light escape? It sounds like the setup to a joke, but it's actually the challenge scientists faced when they set out to photograph a black hole. These cosmic monsters are invisible by nature. No light, no reflection, no shadow in the traditional sense. And yet, we humans, with our telescopes and stubbornness, managed to pull it off. The trick is simple in concept, but mind-blowing in execution. While black holes themselves can't be seen, the matter swirling around them, the accretion disk, glows insanely bright. It's this blazing ring of gas, heated to billions of degrees, that betrays the black hole's presence. And where the black hole sits, it casts a shadow, a dark circle against the glowing chaos. That shadow is what we aim to capture into the Event Horizon Telescope EHT. This wasn't just one telescope, it was a planet-wide collaboration, linking radio telescopes across the Earth to form one giant virtual telescope the size of our planet. From the snowy peaks of the Andes to the deserts of Arizona, scientists coordinated antennas to capture radio waves from the heart of galaxies. The result, an image with unprecedented sharpness. In April 2019, humanity held its breath as the first ever image of a black hole was revealed. The supermassive black hole in the galaxy M87. It looked like a fiery donut, a glowing orange ring with a shadow in the middle. Not exactly Instagram-worthy, but scientifically, it was a revolution. For the first time, we weren't just talking about black holes, we were looking at one. But that's not the only way we see black holes. In 2015, a new window opened when scientists detected gravitational waves, ripples in space-time, caused by the collision of two black holes. These waves traveled across the universe and tickled detectors here on Earth, moving mirrors by less than the width of a proton. And yet, from those tiny wobbles, we could hear the cosmic chirp of the black holes merging billions of light years away. It was like listening to the universe for the first time. These two breakthroughs, the image of M87's black hole and the detection of gravitational waves, prove something amazing. Even though black holes hide from light, they can't hide from us. They leave signatures, whispers, and imprints that we can piece together with ingenuity. And the hunt continues. New telescopes, like the James Webb Space Telescope, are pushing deeper into the darkness, hoping to uncover the role black holes played in the earliest galaxies. Future gravitational wave observatories in space, like LISA, will hear the universe in even more detail, listening to mergers of supermassive black holes. Each new tool is like a flashlight in the dark, revealing more about these invisible monsters. But maybe the most inspiring part is this: black holes, once thought to be purely theoretical, now exist not just in equations, but in images, sounds, and data we can share with the world. They're no longer just the stuff of science fiction, they're a tangible part of human discovery. And somehow, Capturing the invisible feels like the ultimate victory for a species that refuses to accept limits. In the next, final chapter, we'll step beyond science into imagination, asking, what do black holes mean for us, for life, and for our place in the cosmos? Asterisk black holes are more than just astrophysical objects. They become symbols, mysteries, and storytellers in their own right. To scientists, they are laboratories of extreme physics, places where the known laws of nature break down. But to the human imagination, black holes are something much more. They are metaphors for fear, wonder, and possibility. Think about it. No other cosmic object has inspired as many books, movies, or works of art. In science fiction, black holes are portals to other dimensions, shortcuts across the galaxy, or gateways to new universes. From Interstellar's breathtaking depiction of Gargantua to countless novels, where black holes serve as time machines, they become playgrounds for the imagination. These stories may not always be scientifically accurate, but they capture something deeper, our fascination with the unknown. And isn't that what black holes really represent? The unknown, a place where light itself is trapped, where time stretches and space folds, where reality itself seems to collapse. They are nature's reminder that there are limits to what we know, and perhaps limits to what we can ever know. Yet humans have never been content with limits. We probe, we question, we build telescopes the size of Earth. We listen for the faintest whispers of space-time. Black holes also push us to confront big questions. What happens at the singularity? Is information truly lost? Could black holes be bridges to other universes? These are not just scientific puzzles. They are philosophical questions about reality itself. If the universe is a story, then black holes are the plot twists, unexpected, mind-bending, and utterly mysterious. But here's the beautiful paradox. Even as black holes represent ultimate destruction, they also inspire ultimate creativity. Artists paint them, filmmakers visualize them, writers spin stories around them. For something that devours everything, black holes have given us endless imagination. They show us how science and creativity are not enemies, but partners in our quest to understand existence. And maybe that's the true legacy of black holes. Not just the equations of Einstein, not just the images from telescopes, but the way they ignite curiosity in every human who looks up at the night sky and wonders, what's really out there? Could black holes hold answers about life, time, or the multiverse? Or will they forever remain the universe's best-kept secret? The truth is, black holes are less about endings and more about possibilities. They remind us that the universe is stranger than we can imagine, and that imagination itself is our most powerful tool. Perhaps the most important lesson black holes teach us is not about physics, but about ourselves, our endless hunger to know, to dream, to reach into the darkness and pull back light. So the next time you see that fiery ring of the M87 black hole, or hear about the chirp of the black holes colliding, remember this: you are part of a species that dared to chase the invisible, dared to imagine the impossible, and in doing so, turn cosmic monsters into cosmic inspiration. The story of black holes is not over. In fact, it may never be over. As long as there are humans to wonder, black holes will continue to live not just in the depths of space, but in the depths of our imagination.